All right, hello everyone. So today I wanted to go over the notes that we took on literal equations and rearranging equations. I know that we didn't get to finish these in every class. I'm going to try to get to those on Monday, but we'll see what happens. So we started out by adding a word to our glossary. That word was literal equation down here at the bottom. So a literal equation is a formula where variables represent letters and known constants. So that's a lot of school words. So for us, that's going to mean a formula with no numbers. So we're getting to the point where we're going to have an equation, but it's not going to have any numbers in it. It's just going to be letters. So for example, that looks like y equals mx plus b. That's the formula for slope-intercept form. So when we graph a line, that's usually what we used. So each letter means something, and we could replace each letter with a number. So that's going to be the same thing for A equals BH, where this is our formula for area, where A is area, B is your base, and H is your height. So each letter has each letter represents something, but we might not know what it is yet. So we might have to figure out what it is. All right. So if you need to copy this down, just pause the video and then we'll move on. All right. So we did our notes on page 10 in our notebooks like this. So we called this rearranging equations or literal equations. Now, the reason why we're doing this is because this is going to come up in our next unit. The point of this is going to be finding x or some other variable when you have a bunch of other variables in the way. So what happens when we still need to find x, but we still have more than one variable? So we're talking about a situation similar to this one, where we have an x, a y, and a number. Now, by the end of these notes, we're actually going to get rid of the number and replace it with another letter. All right. We want to follow the same process of solving equations, but none of the terms combine. And I'm going to underline or highlight that word none in a better color than red. Oh my gosh, Miss Fields. There we go. So none, because we are not going to be able to combine any of our terms. Like we talked about in our multi-step equation notes, combining like terms, we can't do that here. We will not be able to do that, and you're going to see why in a moment here. So let's take a look at what we have down here. I have a table for the rest of this page. Now, I want to do this so that we can compare our regular normal equations that we're used to seeing and literal equations. Because like it says, you're going to follow the same process of solving equations. But our answers are going to look a little bit different. So what I want to have on one side is normal equations, like we're used to seeing. And then we're going to have literal equations on the other side, which are new to us. So we can compare and contrast and see what how they're different and how they're the same. Alrighty, so let's start out with one. Let's say we have x plus 5 equals 3. Okay, that looks like a one-step equation that we've seen before. So your goal is to get x by itself. You want to solve for x. So when we usually do that, we want to look at the side that has x on it. So let's split this in half. All right. So I'm looking at the side that has x on it. I see this number 5 here. I want to get rid of that 5 on that side so that I can get x alone. So to do that, you're going to do the opposite operation, minus 5. But whatever you do to one side, you have to do to the other, like that. Alrighty, so when we do that, we're going to end up with a 0 here. So that'll leave us with x equals 3 minus 5. Okay, 3 minus 5 is negative 2. Now I know what x is. Okay, normal equation that we've seen before. We've done this before. So let's take a look at what it would be like in a literal equation. Let's say we have x plus y equals 3. The only change I've made has been instead of a 5, now I put in another variable. So I'm going to follow the same process. I still want to get x by itself. I still want x by itself, so this y has to go. So doing the same thing, opposite operation. I see y is being added, so I want to subtract it from both sides. All right, so when we do that, these y's will become a 0, just like the 5's did. That's going to leave us with x equals problem. Okay, so we see 3 minus y. Now, here's when that part where I said none of the terms combined comes in. So we have a number, 3, and a letter, y. Now, the only time you can combine like terms is when they're like. That means they have the same letter. If 3 had a y on it, this would be fine, and we could do that. But it doesn't. This is a normal 3 and a y. We cannot subtract those, so we're just going to write it exactly the way it is. 3 minus y. And that's going to be our answer. That's where we stop. We cannot combine these numbers because they're not numbers. So we're just going to leave it exactly the way it is. All right, so let's try another one. Let's say we have 3x equals 9. Okay, this is another one-step equation. We have 3 times x equals 9. So, since 3 is being multiplied, I want to divide to get rid of it. So, these will cancel out. So that'll leave me with an x equals 9 divided by 3. That's 3. Okay, now we know what x equals. Let's see a literal version of this. So, let's say we have x, y equals 5. Okay, so the only thing I did was now instead of a 3, now we have a y. So I still want to get x by itself. So I'm going to divide by y on both sides. Just like with my 3's, these y's will cancel out. So I have x equals 5 divided by y. Now, once again, this is the same problem that we had in the last one. 5 is a number. Y is a letter. We don't have a y next to our 5's, so we cannot combine these. We cannot do that. So we have to leave it alone. We're going to leave it exactly the way it is. So we have 5 divided by y. All right. And I know this is a tough concept, so don't worry if you don't get it right away. We're going to work on it more in class, but I just wanted to give you a heads up of what we're doing. So I want to do one more of these, only this time this is going to be a true literal equation where we only have letters, and we're going to do the same exact process. So I'm going to take this, make it a little bit bigger. So we have y equals mx plus b. Okay, that's our slope-intercept form that we already talked about. So let's say I want to solve for m. I want to find what m is equal to. So we're going to go through our process of solving, just like we did before. Just like we've been doing in class. Only this time we don't have any numbers. They cannot combine. So first thing I want to do is subtract this b. Remember, when we do our multi-step equations, we want to add or subtract first and then multiply or divide. So I'm going to subtract b from both sides. Alrighty, so that's going to leave me with y minus b on this side because these can't combine, they're different letters. So we have to leave it the way it is. So you have y minus b equals mx because these b's canceled out and became a 0. Okay, so now we have one more step. Since I'm solving for m, I want my m to be alone. So that means we have to get rid of this x. M is being multiplied by x, so to get rid of it, I'm going to do the opposite and divide. Dividing both sides by x. Alrighty, so that is going to leave us with y minus b over x, because we can't combine those. It has to stay exactly the same, equals, well, let's see, our x's cancel out, so that's going to be just m. So we just solved for m. We know m is equal to y minus b over x. Now, I know that looks a little scary, but it's okay because we've done this. This is the same process that we've been doing for the past week and a half, where you want to cancel out the different pieces that you don't need so that you just get to the variable that you want. All right, also, I'm going to cut it off here, but hopefully that helped a little bit with the situation. I'm probably going to find some more videos to help y'all out, but that is going to be it for today. Bye.